Hello student. Um, in this video I am going to start a new topic that is about estimation. Uh, the purpose of any random sample, simple or otherwise, is to estimate the properties of a population from data observed in the sample. So we need to estimate properties of a population. We need to estimate the properties of a population from the data observed in the sample. So suppose a government agency want to know the average household. Here you can see, suppose government want to know the average household income over the population of all households in the India. This is unknown average is the population parameter of interest. Then this unknown average, so at that time the average is not known, that is why this unknown average is the population parameter of interest, and the government is likely to estimate it by sampling several representatives households in India and reporting the average of their incomes. So that is the scenario. We need to understand this scenario because that is the purpose of estimation. So uh, what is sampling error? There are two basic sources of errors that can occur. Okay, when you sample randomly from a population. Okay, when you randomly sample from a population, there might occur some sampling error, and all other sources usually lump together non-sampling error. So there are basic sources of error, two basic sources of error that can occur when you sample randomly from a population. From a population, then it will be sampling error, and from all other sources usually lumped together as non-sampling error. Sampling error result from unlucky samples. As such, the term error is somewhat misleading. Suppose, for example, that mean household income in Indiana is 58,225. We can only assume that this is the true value, and it would not actually be known without taking consensus. A government agency wants to estimate this mean, so it randomly samples 500 Indian households and finds that their average household income 6,495. So here you can see, if the agency then infers that mean of all Indian household incomes is this, and the result sampling error is this, difference between the reported value and the true value. So here you can see this is the error. So note that agency has not done anything wrong. This sampling error is essentially due to bad luck, because whatever thing you have chosen from that, the average is coming that, and the actual average is different. So this might occur because the data whatever chosen or whatever sampled data have chosen randomly, that might be unlucky, which are not giving the accurate results. That is why sampling error might happen. And what is sampling error? That is inevitable result of basing an inference on a random sample rather than on the entire population. And what is non-sampling errors? Is quite different and can occur for a variety of reasons. We discuss few of them. So perhaps most serious type of non-sampling error is non-response bias. This occurs when a portion of a sample fails to respond to the survey. Some portion of the sample might fail to respond to the survey. Then also non-response bias can occur, and non-truthful responses. Sometimes while we sample or while try to survey, then non-truth responses might come, like have you ever had an abortion, or do you regularly use cocaine. So in those type of question, answer might be not truthful enough, and in that way the thing might lead to non-sampling error. And again there is another one, measurement error, and again voluntary response bias. So there are these few error prone examples. There might be many, so you try to go through them, you try to understand them. This is easy to understand. So in case of sampling, we need to understand point estimate. uh, what is point estimate? Point estimate is a single numeric value or a base guess of a population parameter based on the data in a random sample. And sampling error is the difference between the point estimate and the true value of the population parameter being estimated. So point estimate is a single numeric value that is a base guess of a population parameter. So sampling error is dependent on this. Sampling error is the difference between the profit point estimate and a true value. Point that you have estimated using the random sample from the population, and sampling error is from this minus with the actual true value of the population. And sampling distribution. Sampling distribution of any estimate is a distribution of the point estimates from all possible samples. There might be lots of other samples with different sample size from the populations, and for every populations there might be some values coming out like point estimates, and those estimates can be put in a distribution manner, and that distribution will be sampling distribution. And what is confidence interval? Is an interval around the point estimate calculated from the sample data, and that is very likely to contain a true value of the population parameter. Additionally, there are two other key terms you should know. That is, first, consider the mean of the sampling distribution of a point estimate. It is the average value of the point estimates you would see from all possible samples, when this means is equal to the true value of the population parameter. The point estimate is unbiased, otherwise it is biased. Naturally, unbiased estimates are preferred, even they sometimes miss on the low side and sometimes miss on the high side, and they tend to be on target on average. An unbiased estimate is a point estimate such that the mean of its sampling distribution is equal to true value of the population parameter being estimated. So here the point estimate and the mean of the sampling distribution should be equal to the value of the true value of the population. Suppose you are trying to understand the average salary, and suppose you have tried to find out you have find out the point estimate is suppose $50 average, and the actual true value of the population is also $50, then that estimation is unbiased. Unbiased estimation is preferred, but if they sometimes miss, even if they sometimes miss on the low side and sometimes miss on the high side, they tend to be on target on average. And there is another point, that is standard error of an estimate. Standard error of an estimate is the standard deviation of the sampling distribution of the estimate. So we need to understand how this sampling distribution and sampling mean can be observed. Here you try to go through this. Suppose we go through the sample 7.1. So here annual income example, that is what talking about. So we'll go through that. So we are going to study that 40 incomes in the example 7.1. They are showed how to generate a single random sample of size 10. So we are trying to generate single random sample of size 10. For the particular sample we generated, figure 7, you can see in the figure 7, the sample mean was this. Because the population mean of all 40 incomes is this, the estimation error based on this particular sample is difference is this on the high side, means positive, that is the high side. So however, this is one of many possible samples. So this answer, this difference can be for one sample, this difference, and there might be lots of other possible samples with different values. To see other possibilities, you can use state tools procedure for generating random samples to generate 100 random samples use of size 10 from population of 40 incomes. And then you must do this by generating 4 groups of 25 samples each, because state tool limits you to 25 random samples at a time. You can then calculate the sample mean for each random sample and create a histogram of this sample means. So here you can create the histogram, okay, of this sample mean. Okay, what we are talking about, sample mean, the histogram. So histogram is saying that you can then calculate the histogram from this. Although this is not exactly sampling distribution of the sample mean, because there are many more than 100 possible samples of size 10 from a population of size 40, it indicates how the possible sample means are distributed. You can see how the possible sample means are distributed. They are most likely to be near population mean 39,985. So 39,985 very unlikely to be more than about 3,000 from its population mean. So in either way, more than 3,000 population mean is very unlikely to be, and have an approximately bell-shaped distribution. So this is approximately bell-shaped distribution. So here you can understand the unbiased property of the sample mean. So again, you can equate the sample mean, standard error of this sample mean, that is this, where n is the number of samples. So approximate standard error of sample mean. And again, confidence interval for population mean. These are the key terms need to understand in case of whenever you are trying to understand the sampling distribution and mean. So this is one problem with standard error in equation 7.2. Its values depends on the other unknown population parameter sigma. Therefore, it is customary to approximate the standard error by substituting the sample standard deviation as for sigma. This leads to equation 7.3. So approximate standard error for sample mean. As we discussed in the next subsection, the shape of the sampling distribution of x dash is approximately normal. Therefore, you can use the standard error exactly as you have used standard deviation in previous chapters to obtain the confidence intervals of the 4D population mean. Specifically, if you got two standard errors on either side of the sample mean as shown in the expression 7.4, you can see here plus minus, that is why on either side. Okay, you are approximately 95% confident of capturing the population mean. Alternatively, you are 95% confident that estimation error will be no greater than two standard errors in magnitude, same like the normal distribution concepts. Okay, so this is the ultimate equation, confidence intervals for population means, the intervals, total intervals where the sample mean will lie. This is the location, which is not more than $3,000 on each side of the mean. So this is a histogram only. So in that way you can understand the sampling distribution, how we can use them to understand your sampling technique, to estimate the sampling technique, how it is unbiased, how it is errorless, or how much error is there, it is unbiased or how much it is biased. Like that thing can be understand using this type of technique. So you try to go through it again through this data, and again you can understand or you can count these finite population corrections, like standard error of mean with finite population correction factor and finite population correction factor. These are different type of factors need to be understand regarding the sample value. So we'll try to go for more in the next class. Okay, how we can go for sample size selection and what are the summary lead from this simple random sampling. Okay, we'll try to understand the problems related with this and what are the things you need to learn from this, and again this central limit theorem in next video. If you have any doubt, please let me know. We'll try to resolve in over Google Meet. Okay, this is a bit it might be complex also. Try to go to this context, actually content from this book, and try to understand the example through using these equations, and then only you can understand better. Thank you.